get better. So, because it's not usually if I can stand behind a student and work them with them, they have no problem. It's when you get by yourself. And so that's just a matter of like getting your brain right and knowing where you're going to mess up before you mess up. All right, so as we talked about on Friday, f of x, the notation f of x, is the same thing as y. This is just like y equals or f of x equals g of x equals k of x, whatever letter you want to use. It's just notating which function we're looking at. So in this case, f of x is typically the most popular because it's function x, sorry. Given f of x equals 3x minus 3, find f of negative 4. So that x was just replaced with a negative 4 because this is f of x, and they put a negative 4 in its place. So that's exactly what we're going to do. So again, this is what we were doing last week, right there at the end of class. But I wanted to make sure because it's very, man, I have pens that don't work. It is going to be one of those things that will make your life easier in Math 3 and further maths down the line if it's easy now. So you're going to plug that negative 4 in the place of x. So what's a positive 3 times a negative 4? You guys can type it in the chat box or you can holler at me. Negative 12. Beautiful. And then minus 3. We're looking for that output. So if I owe you 12 and I borrow $3 more, where are we sitting? Yep, Zane, perfect. Negative 15. That means I owe you negative 15. And then as I mentioned on Friday, this question, so if you see a function and they give you this, is saying what is y or what is the output when x equals negative 4 or the input is negative 4. So what is the output if x is negative 4? And as we talked about as well, so that means this guy is going to equal to negative 15. You can see this same style problem where the answer is going to be negative 4, negative 15, because it exists on a graph the same way as it does in a function, because every function has a set of coordinates or a table to match it. All right, so g of x, same thing. We just have Frank and Gertrude, no different. G of 0. So again, g of x, we just replaced the x with a 0. And we're going to solve for that output. So what is y when x is 0? What is y when x is 0? So we're going to put a 0 in the place of x. What's 4 times 0? Yeah, Zane, perfect. Yep. Love it. I love it. 0, and then that's going to be 0, and I'm probably writing more than you ever would write, but still, 0 plus 3 is going to give us 3. So when x is 0, y will be 3. Again, you can see that as a coordinate, 0, 3. 0, 3 does exist for function g of x. So like if you were to graph this line, this point would be on that line. So that's another way that you might hear it worded differently in future math class and even in Math 1. But if they say, is this coordinate a function, a part of this function? So does this coordinate make this true? And that ultimately would be 3. So now you decide if both sides end up being, because this goes away, and it is 3 equals 3, which we just solved it. That means that it does make it true. All right, so I'm going to give you a minute. F of x equals a negative 3x minus 3. Find f of negative 2. So I'm going to let you try it with that negative 2. Please. Remember, what does a negative and a negative give us when we multiply? Yep. Okay, positive 6 minus 3. So we're going to give that, and that's going to give us a positive 3. So when x is negative 2, our output or y value will be 3. As a coordinate, that's going to be negative 2, positive 3. Do you want me to do one more, or do you want me to jump a minute? How are we feeling? Is it as easy as I feel like it is? Like I said, I don't want to bore you. Who wants to see one more? One more. All right, beautiful. H of x, so again, doesn't matter. Same story. It's just this is Harry instead of Frank and Gertrude. Okay, so we're going to take our function. 4 is in the place of x. It's h of x, h of 4. So we're going to take our function and put the 4 in the place of x because that's where they put it when they wrote this here. So 4 times 4 is going to give us 16 minus 5, which will give us 11. And I did pick super basic linear equations just so you could get comfortable. And that's what you're doing in your delta today. These are all snatched from delta. So that way it's not the computations that is what you're practicing. You are actually practicing the process. Because when you get into quadratics and absolute value functions and things like that, you shouldn't have to deal with too many of them. But it's fair game. You have calculators. That's a whole communication between you and your calculator issue, usually more than it is figuring out. Once we figure out that when it is written h of 4, this is their x value, and you're solving for your y value. So again, as a coordinate, it's 4, 11. When x is 4, the output will be 11 in function h. So again, the other way they could ask the same question, same exact concept, is 411 a part of a solution to this function? And it is, because when x is 4, y will be 11 when you plug them in and solve them. Now, this is my favorite because in Math 3, everybody gets really good at these, and then they all of a sudden just like, I don't know if it's because there's a time lapse between Math 1 and Math 3 because you don't do as much of it in Math 2, but it's like someone just like, man, I don't know. It gets really hard and really difficult. I like colors, especially in Math 3. This is not super complicated, but colors are fun. So if you're down, I'm down. So h of x. And the biggest thing is most of you are going to be going too fast and not notice. So that's h of x, that's f of x, and then we have Gertrude, our g of x. So we have Harry, Frank, and Gertrude, right? Each function. They will list them, and they do not have to give you the one necessarily they're asking for in order. Like those first 4, there was no other formula or function to plug it in, no other equation. They can give you a list of equations, and then you have to figure it out. So this says find g of negative 4. Does that mean I'm going to use green, orange, or yellow? Yes, perfect. So it is yellow because we're going to go where g is. This says in Gertrude's function, when x is negative 4, what is y going to be? So we're going to take our Gertrude, so negative 5. It's still in the place of x, because remember, this is g of x. We replace that x with a negative 4. So we're going to do the same thing in our function. And then we're just going to solve the expression. Negative 5 times negative 4 is going to give me what? Yes, positive, right? We're going to subtract 3, give us 17. So when x is negative 4 in Gertrude or yellow function, y will be 17. So I have f of 10, green, orange, or yellow. Yep, orange, because we're going to Frank. That is asking, if x is 10 in Frank's function, what is y going to be? Only in Frank's function, because it says f of 10. So we're going to take Frank's function, 1/2. It is in the place of x. So we're going to put it in the place of x as well. So you're going to plug that 10 in there. What's 1/2 of 10? 5. And remember, 1/2 of 10 is the same as dividing by 2. 1/3 of 10 would be like dividing by 3. So we're going to have 5 minus 6. And what's that going to give us? If I have $5 and I spend 6, negative 1. Beautiful. So when x is 10 in Frank, y is going to be negative 1. When the input is 10, the output is negative 1. Those definitions are a little like that vocabulary has stumped some students, but input means I'm putting it into the function. That means it's going to be in the x. Output is what happens when I do all the computations. So I have h of x. Find h of 0. Green, orange, or yellow? Thank you, Zoe. Because that's Harry and Harry, right? H and H. So that's how we match those up. That is h of x. We replace the x with a 0. So we're going to take our h function. Leave out the x. Don't move it to the side. Completely leave it out. You're done with the x. He's gone. We're now using a 0 in his place because that's what it's asking. When x is 0, what is y? 4 times 0 is going to give us 0. We're going to add 4 to it. So our output is going to be 4. Again, as a coordinate, that's 0, 4. Because when x is 0 in Harry's function, y is going to be 4. Last but not least, for this section, f of negative 14. You solve it. F of negative 14. Pick which function, shove him in there, and give me an output. So we did go to the orange function because that is a f, so Frank. It is in the place of x, so we're going to take x out, and we're going to sub in a negative 14. A negative 14. Yeah, mental math. Good. That's good. Just still make sure I'm perfectly happy with that you're the process part. When it gets all hairy and funky, it gets a little weird with the mental math thing sometimes. So we have negative 7 because that's half of 14. Negative 6. Negative 13. So when x is 14, negative 14, y is going to be negative 13. All right, so of course we just did all given input solve for output. When you're given an output, it looks a little different because it says h of x equals 0, just like h of 0 equals 4. But now I'm asking, this is the y value because h of x is the same thing as y, or f of x or g of x equals. Whatever, if it's that equals something else, we did not replace the x. We're saying this function is going to equal 0. Now we're given the y and ask what is x when the y is 0. Or if you think about it, this whole thing is 0, so this whole thing is going to be 0. So 0 equals a negative x plus 3. This goes back to the lovely solving equations. Gotta do a little work now. All right, we're going to isolate our x. What are we going to move first? Yeah, we're going to get rid of that positive 3. And how are we going to, what's the inverse of adding 3? Yeah, so we're going to subtract 3 to both sides. I'm going to go over to the side. Be careful. Very, very easy to lose that negative. Sometimes I like to tell people, whether you're the person who loses the negative. If you put a negative 1 in front of it, more students don't miss it than do at that rate. Because it's hard for you. Most of you don't like leave off a negative 2 or a negative 3 or 10. But with that just little negative sign, sometimes it gets a little weird. So that's negative 1x. What operation is this that's showing? Yeah, right. Any number attached to x without a sign, an operation, is going to be multiplication. So we're going to divide by negative 1. Negative 3 divided by negative 1 is going to give me what? Positive 3. So again, this is saying what is x when y is 0. So as a coordinate, that means 3, 0. This is my input. When I put a 3 into this equation, I should get out a 0. You can check it if you want. Plug it in. Negative 3 plus positive 3 does indeed give me 0. So we're rocking and rolling, and we did it right. Oh, I mistyped. Oh, I just see a mistake that I made on the worksheet. That's what I get for going too fast. Okay, g of x equals 0 again. G of x equals 0 again. I'm going to let you try this guy. I know I only did one. But you have a g of x function, and I want to know what's x when g of x equals 0. We're going to take the whole g of x. And then we're going to solve for x. All right, so we have our 2x here. That's our stinky kid. We're going to move that negative 4. How are we going to move that negative 4? Yes, because that is the opposite of subtraction, or having $4 is the opposite of not having $4, right? So 4 equals 2x. Like we just did that negative 1x, or negative x is negative 1 times x. This is 2 times x, so we're going to divide by 2. These guys cancel out, and 4 divided by 2 is the same thing as saying what's 1/2 of 4. X is going to equal a positive 2. So as a coordinate, positive 2, 0. Positive 2, 0. And I just thought about something. Let's see if I can get this up fast enough to show you. Another way. If this happened to be on calculator active, I feel like in my heart of heart, we're already it's already too easy to be EOC like yet. But I can't tell you enough that if it is calculator active, check it in Desmos. Because some of us are more visual than we are algebraic. So I'm going to take this one, the 2x minus 4. And that was a g of x function. So we did g of x equals 2x minus 4. We can look at this because it says when is y 0? And then you're going to see that negative 4. Now, hold on to your bridges. Hopefully you're paying attention because this blows my mind. If I want g of, when g of x is equal to 0, I don't think it'll do it this way. I'm sorry. I told you negative 4. I'm making stuff up. If you type in what you're looking for, g of x equals 0, and you look for your intersection, your answer is 2. If you want to check it, like if you solved it for x, I'm sorry, you solved it for, if I'm given the x, then it should, why is it not doing it? Oh, because I have 2 of them. That won't work. Then you would see 0. G of 2, output 0. When I had the output, that was where I was looking for their intersection, which was at that positive 2. So for the mixed up page that we were looking at earlier, where we had all the different functions at the top, you can also use Desmos to get around doing some of that as well if you type them in by their name. So h of 4x plus 4 was our other one. And we can do 1. 1/2. So these were some of the functions, and g of x is a little different, but it's okay. So if you were to look at the problem and you saw that it was f of 3 is what I needed to solve for, it will solve it for you. It will pick the right function for you. So 1/2 of 3 is 1.5, minus 6 is that negative 4.5. So as long as you know and have them named appropriately and different, if they all are f of x, and then this is just in different, ooh, hello, I'm having an issue, sorry. See where it now gives me an error sign? Because it doesn't know which function you want it to use. So as long as they are named separately, it will jump on the right function for you. But you can also look at f of 3 and go over to 3, which would be here, x value, and find which function it would look, where it would go, with which function it would go with as well. All right. I just think that's fun because then you don't have to do math for those guys, as long as you can use Desmos fluidly and you know how to communicate Desmos to Desmos. All right, so I want to do another one of the same thing, or do we see with the pattern the difference? One more. Okay, so f of x equals negative 1. You go for it. We're solving when f of x equals negative 1. We did not replace x, we replaced y with a number 1 because it's on the outside of the parentheses. So it is an output. It is that y value. So again, we have negative 1 equals negative 3. Good job, I see it. X plus 2. We have our stinky kid, or our variable. We have a positive 2. So adding 2, the opposite of adding 2 is going to be subtracting 2. We end up with negative 3 equals a negative 3x. That negative 3x is multiplication. The inverse of multiplication is divide. Dividing a negative and a negative is going to give me that positive 1 for x. So again, as a coordinate, when x is 1, y is going to be negative 1. X is always your input because that's what goes into the equation, and your output is what happens when you evaluate the equation. So your y value is output. Input, output. Now, another fun vocabulary lesson, which you're not going to get enough practice of because they don't do a lot of it in Desmos or any of the resources we have to just drill and kill problems. Input and output. Output depends on what you put in. So it is dependent on your x value. So the x value is independent. You make that decision, you throw it in the equation, and it makes something happen. It makes an output. So your x values are input and independent. Y value is output and dependent upon what you put in it. Like what x value goes into the equation depends on what output you get. All right, the next one. So we got f of x equals 6. Is that 6 going inside the equation or outside the equation? So we're going to do 6 equals a negative 5x plus 1. And we're going to solve for x. Minus 1, minus 1. 6 equals a negative 5x. That's a negative 5 times x. So we're going to divide by negative 5. Hopefully you're seeing, and this is supposed to be a positive 5. Trying to read the chat box and type in the calculator all at one time. So x will be a negative 1. When y is 6, x is negative 1. Has a coordinate that's negative 1, 6. In that function right there, in that coordinate, what is the output? Yes, good. So this is our output. It is dependent on what we put in to the equation. So input is independent. Output is dependent on the x value that we were to plug into our equation. Because if we plugged in a different x value, we would get a completely different y value. But we decide what x values we put in a table when we make one. Now, the next 4, I just typed them wrong because I was typing too fast. I wanted to practice more of this. And I was not paying attention to what I was doing. Quite obviously. So disregard these because I have no idea what kind of numbers that's going to give us, but it's not going to be in the nice kind ones that we've been working with so far. But again, this is the same as the last, where it doesn't have to give you a single function and a single input or output. It can give you a list and make you go find it. Do we want to do one more, or do we want to go straight to graphs? Perfect. All right. Now, I need you guys to talk to me. I don't know why. I'm a very visual learner. Like I would prefer to have graphs and pictures and things like that and use the calculator over algebraic. I've become algebraic because I'm a teacher and I need you to see where it's coming from. So for me, these are very hard. Typically, I can put myself in your situation and understand where you're messing up. These guys, I'm not as sure why some of us have a hard time with them. So if you pick up on something that I'm saying that doesn't make sense, ask me, talk to me, okay? All right, find the value of f of 6. Is that 6 the x value or the y value? Good. That is the x because we just substituted that x with a 6. And there's no equal to in a number, right? So we're going to go look where x is 6. And we want to go find our function. There is no function below 6, so we're going to go up. So y is the same thing as f of x. So when x is 6, y is 4. When we put input of 6, we get an output of positive 4. Yep, good call. It is 5. And that's just I promise if I put one on a quiz or anywhere that counts for a grade like that, you'll be able to see it. Not like mine that's printed where I lost the graph. All right, so find the value of f of negative 6. So again, this is f of x. So we plugged in the place of x a negative 6. So negative 6 is our input. That's what we would, if we had a function, that's what we would plug in. We have a function on a graph, so we're going to go to our x value of negative 6. And then we're going to go up and see where that graph touches. Looks like a positive 6. Oh, man, these are terrible. So x values, this is x, so we're going on our x, and then we go find the function and see what our output is. So input of negative 6, output positive 6. And again, this is an absolute value function, so you could have an equation where this guy is a thing. Actually, I think I can. Would be plus 7 plus 7. Do we remember what absolute value bars do to numbers? Makes them positive, right? So if I put in a -6 plus 7, it's going to give me a positive 1. So in this case, it doesn't matter. If there's a negative on the outside, plus 7, and that's where that positive 6 comes from. Algebraically. You do not have to be able to pull that equation from your brain with absolute value functions. It works exactly the same as our linear functions did, though. All right. Short of bad graph, like my picture being a little hard to read because of my printout, can somebody tell me one thing, what they think about this could be difficult, or is it just we need practice, or give me some call outs, give me some help. Okay, so I'm going to go look for x, when x is -2. This is our -2. But this is asking when for this function. So ideally, in the best world, see, I can't see that one good enough. I could write this equation on the side for you. I can go find it. So our y-intercept is a -5. It looks like our slope is, so y equals, it has a -1 slope with a -5 y-intercept. So this would be a function. This would be the function you would get. This is how, like, the top of our paper, our first couple of notes would have looked like this. And then they would ask you to solve for this one. But the problem is they may not give you the function. They just give you the graph. So the idea was here, we plugged in that -2. And that would have given us +2 minus 5 gives us a -3. So at -2, this graph exists when the y value is -3. And that when you don't get the function and all you get is the graph, you're putting in x and going to go find the function. And I say find the function because I've watched students go -2 and be like, there's nothing up here. How do I know where to go? So you have to decide, is the function below it or above it? And that's where you come down. Is the function supposed to touch the graph line? The graph line is the function. Okay, yeah, I'm glad. I was like, oh, I'm not sure I understand what we're saying. So this, so where normally this is your function and then you plugged it in, this is the graph of said function, but they don't give you the function. They give you the graph. So you're trying to see what point on this line in this function, x is -2, and it's when y is -3. So like this one, it says f of 8. So when x is 8, obviously we don't want to go up because then we're losing, there's no function up there, right? It's down here. And I think it looks like it's -4. Perfect. So when x is 8, y is -4. Good questions. Thank you for asking me questions too. So yeah, so this is a quadratic function that is graphed. Whereas like on page 1, we were doing all linear functions and they were not graphed. Your function was given. Now you're getting a graph of a function and doing the same thing. X, if it's inside the parentheses, that's your x value. So you just go to that x value and go figure out where it touches the function. And then go find out what that y value is. Like that. Okay, hopefully this is not a bad next one. So this one says f of x equals 0. So you use the graph for f of x equals 0. How is f of x equals 0 different than the last two we just did? Right. There's no value in the x spot. I have the y spot. So I'm looking at y is 0. So I want to go where y is 0, and that's there. So f of +6 is equal to 0 because that would be 6, 0. Also, just some fun facts for vocabulary and things that'll make your life easier. If y is equal to 0, that is the x-intercept. That is going to be where that graph touches the x-axis every stinking time. If y equals 0, that means I didn't go up or down at all. That means I'm only going left and right. It's going to stay on the x-axis. If x is equal to 0, it's going to be your y-intercept. Always. And sometimes that'll just help you a little bit, not having to think so hard. So you'll probably hear me say that a couple different times when it doesn't seem like it's pertinent, but it'll save you some brain power along the way if it sticks. All right, so this one says f of 7. Is that 7 the x value or the y value? X value, right? Because it's inside the parentheses. So we're going to go over on the line and go look for when x is 7, which is here. And then go find my function, which is below it. And it looks like it's going to be -1 for our y value. And that's because I traveled back there. So input of 7, output of -1. Input is independent. Your x value is independent. And your y value depends on what x value you choose to go look for. All right, I got f of 8. Is that 8 x or y? No, it's inside the parentheses because that means it would look like this. When x is 8, what is y? So when x is 8, we're going to go up because that's where that function is. What is y? Looks like 4. And that 4 comes from right here. So our answer would be 4 to that question. Last but not least, that's all I got. Yep, one more. One more for the road. It's hard to see, but f of x equals 2. Is that 2x or y? It is y. He's not inside the parentheses. And remember, f of x is the same thing as y. So when this is asking, what is x when y equals 2? What input would give us an output of 2? Again, how many times have you read a problem, especially in the last couple of years of math, where you're like, I don't even know what it's asking me. And it's just a vocabulary change. So x, what input would give me the output of 2? Yep. So when y is 2, we're going to go up to 2, and then we're going to go look for our function, and it is indeed -6. So -6, +2. X value, then Y value, always in your coordinates. Now, that's another fun thing. I think you guys did a lot of work on Desmos in 8th grade, so that's awesome. If you're part of Connect, for sure, Miss she seemed to really drill it. If you are questioning whether you wrote the coordinate right, because I will say Math 1 all the way through Math 4, there's a handful of students that just get the X and Y's mixed up. If you will take the time to open Desmos and type in whatever answer you think it is, and if that dot's not sitting in the right quadrant, remember this is quadrant 1, 2, 3, and I'm just saying that because it's easier to reference the quadrants that way if you know that way that they're numbered. If it's sitting over in quadrant 1, you've obviously put them in the wrong way, whether you have the negatives or positives mixed up, or most people have the X and Y mixed up. Again, just going off watching other students and the most common misconceptions. All right, guys, we're a little early. Is anybody upset about that?